All right, this is Geometry, Chapter 12, Lesson 2, on page 491. It deals with one concept, and that's tangents. Okay, so you've learned the tangent equals opposite over adjacent. That's right. That is not what this is. This is dealing with a line in a plane that intersects a circle at only one point.
Are you going to still use the tan lesson?
No, we're not. However, how many times does a chord intersect a circle? 2 points. At how many points does a secant line intersect a circle? 2. A tangent line only intersects a circle at 1 point. 1. And only 1. Okay, so I'm going to draw a tangent line over here. It just touches it and keeps moving. It's just on the edge of the circle. So it only intersects the circle at 1 point. When a line intersects a circle at 1 point, we call it tangent. So this line is a tangent line. This line is a secant. This line is a chord. And this segment is a radius. So you see the difference between the 4 actually types of lines. Okay, well now there's also some interesting things that happen when we have lines tangent to a circle. When a line is tangent to a circle and the radius of a circle intersects the circle at the exact point of tangency of that line, where the line intersects that circle at 1 point, we call that the point of tangency, where that line is tangent to the circle. When a radius intersects that point of tangency, something is always true. The radius is perpendicular to the tangent. Just like when we had a diameter, it's very similar. When we had a diameter that we knew bisected a chord, we knew it was perpendicular to it. When we have a tangent line and a radius to the circle at that point of tangency, then the radius is perpendicular to the tangent line. Now what if we had 2 tangent lines? From one common point. They could actually keep going, but from that common point, here's another fact that is true. Are y'all paying attention? The length from the intersection of the lines to the point of tangency, they're always equal. Always. So actually, I could draw several tangent lines to a circle. And if I just label them, both of these would be equal. Both of these would be equal. These two from this point, and these segments would be equal. Such that if I just gave you one of each of these values, I'll just make up numbers. We'll just go in order. Then we could find the perimeter of this quadrilateral. So it'd be 3 plus 4, which is 7. So that side is 7. What would this be? 4 plus 5, which would be 9. What would this be? 5 plus 6, which would be 11. 6 plus 3, which would be 9. And so whatever the sum of those values are, you could actually know the perimeter, couldn't you? Because of that one fact that a line, two tangent lines from a common point, the distance from that common point is equal. All right, so let's look at our definitions. Yes?
If it's a circle, like a perfect circle, wouldn't it always be a square? Or a rectangle? Or wait, not a square? Wait. Kind of on the side.
Okay, I'm going to show you what will always be a square. Where I could possibly have a square. If I told you the radius was 5. Then this would be a square. The outside is not always necessarily square. Doesn't have to be.
Well, if the line, all the lines are touching the circle, I don't see how. Like if I don't see how it could be square. Because circles are like.
They are perfect.
But if it's like an ellipse, then it could be.
It's not necessarily a square if it is a circle. What is true is your opposite angles are always going to be equal. These opposite angles are going to always be equal. Because the point of tangency, like it just depends on the direction of the line. Like it could be here, and this one, they could just intersect way out here, and then I could have real close intersections. It's the angle, the slope of the lines. Like I could have that. And
I guess it's on the
right, because it's the slopes of the lines are different. So the tangency, I mean, you don't have to, it just depends on the slopes of the lines. I could have this one, the lines sort of looked like the same slope, but the point where they're concurrent doesn't have to be so close to the circle based on the slope of the line. However, if I know that my radius equals one of these, then I know that this is a square, or at least a rhombus. Might not be a square, but it would absolutely be a rhombus, because we don't know that those are 4 right angles. You can't know that, but you can know it's a rhombus. All right, so definition: a tangent to a circle is a line in the plane of the circle that intersects the circle at exactly one point. And if the line tangent to a circle, if it is tangent to a circle and it's perpendicular, it is perpendicular to a radius drawn to that point of tangency. I said that. And if a line is perpendicular to a radius, then it is tangent to the circle. All right, I said that. All right, so now this is what I'm going to review. Now, what if we have a line tangent and a secant and a secant line in a circle? Like, let's pick easy numbers. There are no easy numbers, are there? Maybe this one's easy. Like this length is 15. It doesn't go through the circle. It's only the outside. This length is 9. This length is X. It's the same rule as before. I'm going to go ahead and do the A's and the B's. All right, so if we have A, B, C. So it's the outside times the length of the hole. The hole is the outside. Equals the outside times the length of the hole. All right, so we apply it here. The outside which is 15, times the length of the hole, which is the same value, equals the outside times the length of the hole. What's 50 times 15? Is that 225? 225. Distribute the 9 to both of those terms. That's 81 plus 9x. Subtract the 81. What's 225 minus 81? Is that 144? What's 144 divided by 9? What is 144 divided? 16. So x is 16.